All right, welcome back, my sixth graders. We are going to be hitting into lesson 2-5 here. Let's begin. I got all the even ones, you got all the odd ones. So it says find the distance between each ordered pair. You notice that each one of these ordered pair has an x and a y coordinate to it. And since I know that the y coordinate in these two ordered pairs are both 8, I'll highlight that there for everyone to see. And there is really no distance between that. They're lined up perfectly on the y coordinates. So we're just looking for the distance of x away from each other. And that means I'm going to have the absolute value of -2 plus the absolute value of 7. The absolute value of -2 is 2. Absolute value of 7 is 7. And 2 plus 7 is 9. So that's going to be 9 units. All right, let's go to number 12. Once again, we remember that these are all labeled XY. And I can see over here that the Y's again are the same. So I'm just going to deal with the X. And that's going to give me 12.5. The absolute value of 12.5. And the absolute value of -4.5. Now I know the absolute value of 12.5 is going to be 12.5. I could put 12.5, but since they're writing this as fractions, I'm going to leave them as fractions. And the absolute value of -4.5 is 4.5. Now I can simply add these. 12 and 4 is 16, and then 1/2 and 1/2 is 1. So 1 plus 16 is 17. All right, I got number 14. And we're going to do these the same way we did these up here. We're looking for the ones that are the same. We see the X and the Y. Again, the Y is the one for me that's the same. If the X was the same, then I would use the X, but since the Y is the same, I'm going to go ahead and use, or excuse me, yeah, if the X was the same, I'd use the Y, but since the Y is the same, I'm going to use the X. I'm going to use the absolute value of -5.4, which is 5.4. And if I was to write it out, then I would put the absolute value of -504 plus the absolute value of 0.6. And that wasn't 504, the 5.4. Sorry about that. Okay. And we know the absolute value of -5.4 is just 5.4. And we know the absolute value of 0.6 is 0.6. Remember, the absolute value is how far the number is away from 0. So whether it's positive or negative, it's going to be positive units away from 0. Well, 5.4 plus 0.6, plus 6, remember we have to line up our decimals here. 5.4 is going to get lined up with 0.6. And I know that 6 and 4 is 0. Here, the 1, that's 10, right? And then we're just going to have a 6 over here. That tells me my answer is going to be 6. So this tells me 6 units. That's my answer. All right, let's go ahead and get to number 16. Number 16 says find the distance from the roller coaster, number 1, roller coaster 1 to the swings. Well, we've got roller coaster number 2, number 3 here. Roller coaster number 1 is right here. And they put a nice little dot here for us. It said to the swings, and that's right here. They're both on the y coordinate at 1, 2, 3, 4, 5, 6, 7. So the y on both of these is going to be 7. Remember, there's 2 coordinates, right? And each one is going to be an x coordinate and a y coordinate. Sorry about that. An x and a y for each one of these. And the y is always where it goes up and down. So the x is where it goes left and right. And the roller coaster is 1, 2, 3, 4, 5, 6. You see that? 6. So I went back, so that's going to be -6. And then the swing is just at +1. much like we did over there, we take the absolute value of -6, that's going to be 6. We add it to the absolute value of 1, which is 1. That tells us we have 7 units. All right, let's go to number 18. Find the distance of roller coaster 2 to roller coaster 3, and then to the water slide. Oh boy. Okay, so roller coaster 2 to roller coaster 3, they're both on, let's see, 1, 2, 3, 4, 5, 6, at the -6. Right, so I'm going to be going by the y-axis, right? The up and down distance between them. I could just count this 1, 2, 3, 4, 5. That'd be easy. But I know the book wants me to do a certain way. They're going by x and y coordinates. So both of my x's are this one are going to be at -6. Remember, x always comes first. And then we have the first roller coaster is at 1, 2, 3 below 0, so that's going to be a -3. And the next one is going to be 1, 2, 3, 4, 5, 6, 7, 8. So that'd be -8. And I know that the absolute value of, let's see, this time we're not dealing with the opposite side of an equation or of our quadrant. So where normally we've been adding these together, remember, this time we're just counting how far it is apart because it's in the same quadrant. This is 1, 2, 3, 4, 5. So that tells me there's a difference of 5. Okay, and some people are saying, shouldn't I have gone ahead and taken the absolute value of both of these? No, that only is for when I'm going across a quadrant. Because look what happens here. If I do that, I'm going to have 3 plus 8. And we know that this is not 11 units away from each other. Okay? And now it says, and then to the water slide. Now we're crossing over to the water slide across my y-axis. Okay? So that's going to be, now is when we go ahead and do that. We'll have, well, they're both at negative, let's see, -8, right? This is -8. So our y is now the same. And so let's cross this out because really didn't need to do that. I want to just show that it would be wrong to go ahead and use the absolute value on the same side. But now I'm going to have my x is going to be, well, this one was -6 and -8, right? -6 was x, and then -8. And then over here we have, well, this is going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be +8, and then a -8 going down. And now we do the absolute value of these. This is going to be the absolute value of -8, which would be 8, added to the -6. I'm sorry, that was not. We have the same y coordinate, so we're going to be using the x coordinate. So this would be 6. The absolute value of -6 is 6. The absolute value of 8 is 8. And 6 plus 8 equals 14. So now we have to add 14 to the distance that there was between the roller coaster, right? And 2 and 3. So that's going to give us 19. So 19 units it would take to get from roller coaster 2 to roller coaster 3 and then over to the water slide. All right, let's go to number 20. What is the distance from H to J? H to J. Now this would be a difficult question to answer if all I had was the information shown here, but let's read on. it says in 20 and 21, use the coordinate plane at the right, but it also says the graph shows the locations of point G and H. Point J is graphed at n minus 3. You see, without knowing where point J was, that would have been a hard question to answer if I didn't know that J is graphed at n minus 3. Now, I don't know what n is, but I do know if this is n, then n has to be the same number, right? So let's see, if n is the same number and the first number is always x, that means my x coordinate has to be the same over here as this one. All right, then it says n and negative 3. So if this is negative 6 going down, right, then negative 3 must be halfway between there. Right, so it's got to be about right here. Right, lined up with this one. Now it says the distance from point H and to point J, H to J, let's see, is equal to the distance from point H to point G. It's equal to H to G. Okay. Now, let's see, if I'm looking at this, do I know the distance from H to G? Well, my second digit is 6, so I know I'm calling down 6, right? All right. Let's see, from H to J. Now remember, J is going to be here, right, at n minus 3. Okay. And we want to know how far, let's see, what is this is from H to J, right? H to J. And they're saying that, let's see, this was n and negative 3. Well, if this was negative 3, and both of these are n, then we know that our first coordinate was, we don't know what n is, right? We'll just put n, because that's x. And then we'll put negative 3, because, well, actually negative 6, because that's h. And this is 2j, so that's going to be n, and then minus 3. All right, so what's the distance from h to j? Well, we know that there's going to be 1, 2, right? 1, 2, 3 spaces. So 3 units. The distance from point H to point J is equal to the distance from point H to point G, H to G. Okay? So, well, let's see. The graph shows the location of point G and H. Point J is graphed at n minus 3. The distance from H to J is equal to the distance from H to point G. So if this was 3, then this must be 3 units as well. Okay? All right. But they didn't ask me that, so I'm just going to leave it alone. Let's see here. We got, I did 20, so 22 is mine. Suppose A, B, and C are all negative numbers, okay? They're all negative numbers. How do you find the distance between point A, B, and AC? Well, how would all these numbers be negative, whether they're X value or Y value? Remember, the only place they can all be negative is in my quadrant 3 down here, because then I'm going to the left of my 0, right? And that would be negative numbers. And I'm also going down, that would be negative numbers. So now that I know that, how can I find the distance? Remember, they're all in the same quadrant. So am I going to go ahead and add them up? Remember, I only add if I'm going to the opposite side quadrant. So in this case, the answer is no. I'm not going to add them. I'm not going to find the absolute value of them. I'm going to find the difference between them. Because if A, B, then I know that, let's see, if A is the same on both of these, then I know what I'm comparing is B and C, right? Let's just say A, and remember that's X, is here. And I don't know what it is. We could just say it's -3 for all we care. If we were to go down, and we know B and C are not the same, right? That means, let's just say B is over here, right? And we know C is over here. We don't know what they are, but we know they're not the same. So I'm simply going to take the number, whatever I have here, and subtract it from here, right? Because if I have 6 here and 3 here, I wouldn't add these numbers, right? I would have to subtract 3 from 6, and that would give me 3. So I would find the difference between the two of them. Let's see, how do you find it? Let's see, let's use smaller letters. Find the difference between B and C, right? And number 24 is mine to do, right? So let's knock that out. The rectangle ABCD, shown on the coordinate plane represents an overhead view of a piece of land. Each unit represents 1,000 feet, okay? Each unit represents 1,000 feet. What are the dimensions of the rectangular piece of land? Okay, if each one of these units represents 1,000 feet, and they want to know what are the dimensions of this piece of land, then I know this is going to be, wow, well, this is kind of in the middle here, isn't it? So this is going to be kind of complicated. I would say that this is 1, 2, 3, 4,500, right? And this would be 1, 2, 3, 4, 5,500. So when I write that out, I would have 4.5 would be 4,500, right? And feet. And then I'd have to multiply that, because it's dimensions, they're not asking for the area, by 5.5, which would be 5,500 feet. Okay? And I guess that would be my answer, because they never asked me for the area at all. So 4,500 feet by 5,500 feet, or you might have 5,500 by 4,500. It doesn't matter if you switch these around. All right, that's all the ones I had to do. You guys got the rest, and I'll see you in class.